So go to 8 first. Does everyone have the book in front of them, or see what the problem is? I want to make sure that you aren't just like listening to what I'm saying. So just run that bus trip, each of the N buses that would be transferred passengers.
You have to start stacking.
So again, cover up multiple choice. Don't even get distracted by the choices that are there. Does anybody remember what the 2 strategies you can use for these type of questions? The ones that give you variables and the word problems.
Like circle all the variables and what the answer, like what it's asking.
Definitely. So that's a big strategy to reduce silly mistakes for all the questions, and specifically for this one too, because there are a lot of variables going on. And what it's asking you for. What are they asking you for?
The relationship of all the variables.
Okay, so they're asking, in this case they aren't asking you to solve for just one variable, they're just saying what's the relationship between them. Still important to know that. What are those 2 strategies for actually solving the question? Any question that has variables and word problems.
Got an equation for each sentence.
Okay, so for word problems, you want to approach each sentence like it's an equation. So using that strategy, how do we go about? So like the first sentence is the total of K passengers went on a bus trip. So that's not really an equation. We can just say, look, there's K passengers. K equals passengers. Again, new people, my writing's terrible. That's why I'm going to say what I'm writing so you can understand it. And then sentence number 2, each of the N buses that were used to transport the passengers could seat a maximum of X passengers. So there's N buses, and each of them has X passengers. So the moment you read that, the first thing I think is, what's the total number of passengers that could go? Like what, if you have N buses, what's the really?
N times X.
N times X, right? So total, you think immediately is NX, because you're N buses, X passengers per bus. So you multiply them, you get NX passengers. Third one, if one bus had 3 empty seats and the remaining buses were filled, which of the following expresses the relationship among NX and K? So you've already preempted what the next thing is going to ask you. It didn't take too long to figure this out, right? That's just thinking. So the last sentence is basically saying all the buses were filled except one. And in that one we had 3 empty seats. So how do you translate that into like a formula? If you already have an NX, so how many, again, this is the total number of passengers that could have come on the trip. Could have come on the trip, but only K came on the trip. So first of all, does NX equal K?
No.
No, that's wrong. They aren't, because 3 were empty. So where do you add the -3? Which side do you add the -3 on? NX, right? So it's basically the max you could have is NX -3 equals how many actually went. Okay, and that's your answer. So strategy 1 was to convert every sentence into an equation or a statement that takes away the words. And that's you could leave it all in terms of variables. The second strategy for any of these, and for this one it could be more work than it's worth, but for other ones it's what you should do, is to actually plug in numbers for these variables, right? So like if you said there's 100 passengers total, right? And then say there's again, this is more trouble than it's worth, because it's kind of like you have to have a sense of what's going on in the problem before you actually even plug in the variables. For this particular one, actually, it's better to just do it the way we talked about. Otherwise, you'd confuse yourself. And the way you tell the difference between those two is I guess, I don't know, do you have a sense of like how to tell the difference between those two? I think a lot of it's just intuition.
Yeah, it's intuition. This is a relatively simple problem, so you just know you've got it when you've got it.
Right, so it's practice. I mean, this was some of your first practice test. But I mean, after you've taken a couple, hopefully you've seen enough of those types of things, you aren't missing them. Number 9, figure out y and x parallel to n, what is the value of x? So we reviewed parallel lines once. I'm going to draw this. What's the relationship between this angle and that angle? Yeah, they're the same, right? Interior angle theorem or something like that. Opposite interior angles or whatever it is. These two are equal. That's equal. That's equal, right? So that's the main thing you have to know about parallel lines, and that'll be tested often on the SAT. So what they've actually drawn in is 2 parallel lines where salvage this. They say this is 80 degrees here, and they say this is 50. What does that make this? 30, right? Because they're equal. And okay, so if that's 30, there's another thing you have to look and see that if I have a line and that's another line intersecting it, what's the relationship between this angle and that angle?
Supplementary.
Okay, yeah, so they add up to, what does that mean?
They add up to 180.
Add up to 180, right? It's a line, they add up to 180. So this is a line that you have here, and you're trying to find this thing, which is x. So what is x?
150.
150, because it's a line, you have 30 here, and x, so 30 plus x equals 180, so x is 150. Right. So there are a lot of geometry problems where you have to draw on a couple different things. You just have to be able to spot that, and I think people who've been here for 5 weeks can spot these things pretty easily by now.
That's a good example of a problem where there's several different ways to get the same answer too that are equally good.
Right, right. So whatever works for you. 11.
Yes.
So this is a word problem. So what's the strategy we use for word problems?
Making sense in equation.
Making sentence in an equation. So the first sentence is you exchange the front wheel for a wheel that had 1/2 the diameter of the back wheel. So that I mean that's a little confusing, right? Just reading it. So you may have to read it twice. So she exchanged the front wheel for a wheel that had 1/2 the diameter of the back wheel. So what do you want to call the diameter of the back wheel? Sometimes they'll give you variables like k, n, and x, as they did in number 8. Sometimes they won't. So in that case, you have to actually come up with variables for these things. So the diameter of the back wheel, you said what?
2x. If
2x?
the front would be x.
Okay, so if you want to
do it
say,
the other way, x and 1/2 x.
okay, yeah, so it's whichever one you want. And you said 2x first because you know, fractions should be easy, but why get into them if you don't have to?
Yeah.
Right, so why not just use 2x and x instead of x and 1/2 x? So, so you're saying front wheel is x. So front wheel diameter, but what do we want to, so like, yeah, front wheel diameter equals x, and then back equals 2x. And remember, it's diameter. Right, a lot of times they'll ask, this is like a silly mistake, Haven, right? They'll say diameter, and you'll consider that radius. Right, you need to make sure, this is like what I would have underlined diameter in this case. So now when Sinai rides the bicycle, how many revolutions does the front wheel make for each revolution of the back wheel? So that you can't really make into an equation, but you just have to reason that out. Like what are they asking you to compare? They're obviously circles that they're asking you to compare. What property of the circles do they want you to compare?
Circumference.
Circumference, that's easy. So what's the circumference of either? Of this one?
X pi.
Circumference is x pi, right? It's pi d.
Yep.
And this one,
2x pi.
2x pi. Right. So every time the back wheel revolve is once, how many times does the front wheel revolve? Twice. Right. Now, if I were to ask you to compare the areas, what's the difference in the areas between the front and the back?
X.
So what's the area of this one?
Quarter.
quarter pi.
quarter pi,
And pi.
and pi. Right. This one's length, one represents length, one represents area. Cool. So that's 11.
If you guys are comfortable with subscripts, using something like d sub f and d sub r would work well there.
Right.
But
So
I
in
don't know if
physics
you
you
are
get
or
that.
not.
Yeah. In physics, I mean, you like if you haven't gone to subscript variables yet, which you may not have. I think that comes more in AP physics or college physics. Like you'll see it soon, and that as what you mentioned, it would be something like what did you say?
d sub f and d sub r,
Yeah, D
diameter front and diameter
and
rear.
T back.
By should be something.
Right, or D rear. So that's it. I mean that's my preference too. And if you ask this question, you should take notes too on it. Best one, I find that note taking is better, like a more active way to remember stuff. 14. How many ordered pairs of positive integers? 2x plus 3y less than 6. Okay, so what, like just reading through this, what would you underline? Positive integers. Right. So that means 0 is out. So your options are x and y can only be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So neither of them can be 0. So what's the minimum x can be? 1. So if x is 1, like here you consider the cases, because this is one of those problems that I always worried about, because it would say something like, if we have a circle and we draw a rectangle here, how many other rectangles of the same perimeter could be drawn inside the circle? Infinite, right? And this is a problem that we went over before, but basically it's symmetry, so you kind of have to just know it. Or like be able to reason it out. It's more logical thinking than just math solving. So for this one, how do you logically reason 2x plus 3y is less than 6? The way I go about it is I say, look, x can't be 0, so let's just say x is 1. And it's sufficiently small that you can actually write down all the ordered pairs, and you should. Because if you don't, you could miss one. So when x is 1, that means it's 1 comma something. What is y? If the maximum is 6. It can't be equal to 6, right? Is this the one silly mistake you were talking about?
Yeah,
You said
in
that.
more ways than one.
Yeah, you said less than or equal to?
Yeah, I did that, and I totally screwed up the zeros. I used zeros.
Oh, you did use zeros, yeah. So if you had underlined positive
Yep.
integers and, I guess, circle the less than?
Yeah, I don't want to underline it.
Not yeah, you don't want to underline that. It's a case where you wouldn't, yeah. So what does y have to be, basically? 1, right? It couldn't be 2. So, and then if y was 1, x has to be 1. So it's the same point. It's not 2 different points, right? So it's basically, the answer should be 1, right? How does that change if it was less than or equal to 1? So you have 1, 1. What else do you have?
I don't think
It
it'll
will.
change. It's mainly the zeros that
Wait,
change.
0.
Wait,
Okay,
does,
0.
doesn't
Yeah.
x and y have to be different? That's what I thought.
No, it doesn't say that.
Oh.
Yeah, it doesn't say that, yeah.
Oh, because I used 2, 1. I thought that worked. Oh, no, it doesn't. That's 7. Just kidding. I still got it right, though. Oh,
Yeah. That's good. Those are sometimes forgiving.